In our previous videos, we found that this chocolate has a resemblance with the Earth's interior structure. At the central part of this chocolate, we have a whole hazelnut and it is in solid form. So just like this chocolate, the Earth's central part is almost solid. And do you know what it is called? The central part of the Earth is called core. Another name for core is barysphere. As you can see in this picture, we can see the three layers of the Earth, that is crust, the outer layer or the uppermost layer, mantle, the middle layer, and core, the innermost part or the central part of the Earth. In this video, we will study about the central part of the Earth in details. So what separates core and mantle? In our previous video, we learned that the boundary that separates crust and mantle is Mohorovic discontinuity. In this picture, this dotted line is the Mohorovic discontinuity. So just like Mohorovic discontinuity separates crust and mantle, the boundary that separates mantle and core is Gutenberg discontinuity. Gutenberg discontinuity is this dotted line in the picture. Now, let us revise what is discontinuity. Discontinuity is a zone where we find a sudden and significant change in physical properties. Physical properties like state. See, we already know that mantle is in semi-solid form and core is in solid form. So at this transition zone or at the boundary of mantle and core, there is a change in state from semi-solid to solid. So the Gutenberg discontinuity marks a transition between mantle and core. So now let's study more about core. We already know that core is located at the central part of the Earth. Now let's study about its characteristics. That core is almost solid. According to recent research, core is in superionic state. Specifically, the innermost part of the core. Now, why is core in this state? This is because core is located at the center or the deepest part of the Earth and it experiences immense temperature and pressure. And due to this, core is found in superionic state, that is, it is neither solid nor liquid. So, we can say that the Earth's core is almost solid because it experiences extreme pressure from the other two layers lying above it. Now, how much is the extent or the width of this layer? The approximate thickness of core is 3,500 kilometers. The radius of the Earth's core is 3,500 kilometers, that is, see, this much is 3,500 kilometer. This is the radius of Earth's core and the extent is 3,500 kilometers. Now, if you double this figure, we will get 7,000 kilometer. So the diameter of Earth's core is 7,000 kilometer and it is greater than the Earth's radius, that is 6,400 kilometer. 7,000 is the diameter of Earth's core and 6,400 kilometers is the radius of the Earth. So the diameter of Earth's core is greater, which means that Earth's core is a very thick layer. Now we already know that as depth increases, temperature also rises and the Earth's core experiences extreme temperature. The Earth's core has a very high temperature of about 5,000 degrees centigrade. So the average temperature of the Earth's core is very high, and that is 5000 degree centigrade. Now, as I already discussed that core is located below crust and mantle, and we already know that density also increases with increase in depth. So core is the densest of all the three layers, and the density of core ranges from 9.9 to 15 gram per centimeter cube. So here we have the characteristics of core. The core is in almost solid state. The approximate thickness of core is 3500 kilometer, and the core has a very high temperature of about 5000 degrees centigrade, and the core's density is also very high. Now, just as mantle is divided into two layers, that is upper mantle and lower mantle, Earth's core is also divided into two layers. Let's learn about that segregation. In this picture, you can see that we have two divisions of mantle, upper mantle and lower mantle. Similarly, the Earth's core is also segregated into two parts: outer core, the outer layer of the core, and inner core, that is the innermost part of the core. Now, so Earth's core is divided into two layers, inner core and outer core. Now, these two layers of core are not same. So let's learn about the point of differences between these two layers. The first point of distinction between these two layers is their thickness, or the width of these two layers. The thickness of outer core is about 2250 kilometers, and the thickness or width of inner core is 1250 kilometers. So from these figures we can understand that the outer core is thicker than the inner core. The second point of difference between these two layers is their state. The outer core is in liquid state, whereas the inner core is in solid state. Now, outer core is composed of an alloy of nickel and iron, while inner core is entirely composed of iron. So we noted 2 points of difference between outer core and inner core. Now let's learn about the last point of distinction between inner core and outer core. So the last point of difference between outer core and inner core is their temperature. The temperature of outer core ranges between 2200 degrees centigrade to 4900 degrees centigrade, and the temperature of inner core is obviously higher than outer core, and it is about 7200 degrees centigrade. So, and this is very obvious because inner core is located below outer core, and we know temperature increases with increase in depth, and therefore inner core has a higher temperature. So here we have the differences between outer core and inner core. Outer core is thicker than inner core. Outer core is in liquid form and is rich in iron and nickel, while inner core is in solid form and it is rich in iron, and inner core has a higher temperature than outer core. Now look at this picture. This is the complete picture of the Earth's interior structure. Crust is the outermost layer of the Earth. Then below it is located upper mantle, and below upper mantle we have lower mantle. Upper mantle and lower mantle together comprises of the middle layer of the Earth, that is mantle. The central part of the Earth is core, and Earth's core is divided into two layers, outer core and inner core. So till here we discussed what is core, and then we discussed in details about the characteristics of core. We also discussed about the two divisions of core, that is outer core and inner core. Now let us study about the importance of core. Now you must be knowing that if you leave a magnet freely, it always rests in north-south direction. Now why does this happen? This happens because free magnets always align itself with the Earth's magnetic field. This proves that the Earth behaves like a magnet. Now let's find out the reason behind this fact. So we just discussed that free magnets always rest itself in north-south direction. Now the needle of a magnetic compass does not point to the geographical north, but it points towards the magnetic north. See, in this picture we can see that the needle of a magnetic compass is pointing towards the magnetic north pole and not towards the geographic north pole. So from this picture it is very evident that the magnetic north pole and the geographic north pole are not the same. That is, these two poles do not coincide. So apart from the geographic north and south pole, the Earth also has a magnetic north pole and a magnetic south pole. This indicates that the Earth behaves like a magnet. Now let's find out why. The Earth behaves like a magnet because the Earth's core is composed of nickel and iron, which is also known as ferrous. If you remember, when I discussed about outer core and inner core, I mentioned that outer core is composed of an alloy of iron and nickel, while inner core is composed entirely of iron. So in short we can say that Earth's core is composed of nickel and iron. So Earth's core is also called Ni, where Ni stands for nickel and Fe stands for ferrous or iron. So Earth's core is also known as Ni because it is composed of iron and nickel. Now these elements like iron and nickel have magnetic properties, and due to the presence of iron and nickel in the Earth's core, the Earth actually behaves like a magnet. Now before we proceed with our lesson, can you help me to answer this question? Why does the Earth's core behave like a magnet? Is it because it has a high temperature, it has a high pressure, it contains iron and nickel, or is it because it is in super-ionic state? The correct answer is it contains iron and nickel. I just discussed that Earth's core behaves like a magnet because it contains iron and nickel, and these elements have magnetic properties because of which the Earth also behaves like a magnet. So now let's continue with our lesson. We just discussed that Earth behaves like a magnet and it has its own magnetic field. Now how important is Earth's magnetic field to us? The Earth's magnetic field helps us to set the direction of compass needle. Because in the video we saw that the needle of a magnetic compass always points to the magnetic north pole of the Earth. So from this we can conclude that the Earth's magnetic field helps us to set directions. So just imagine what the sailors in ancient times would have done without the Earth's magnetic field. They couldn't have reached their destinations without the Earth's magnetic field. So the Earth's magnetic field is really very important to us. So just as we use umbrellas to protect ourselves from the scorching heat of the sun, the earth also has a mechanism to protect us from the harmful UV rays. So what is that mechanism? Let's learn about it. Apart from the blanket of air, that is atmosphere, the earth also has another weapon to protect us from the harmful UV rays of the sun. As in this video, you can see that the harmful solar radiation that comes from the earth are being deflected by the earth's magnetic field. So the earth's magnetic field protect us from the harmful solar radiation. We just saw how the earth's magnetic field deflects the harmful solar radiation. In this picture we can see the same thing. See, the harmful solar radiation coming from the sun are being deflected by the earth's magnetic field. That is, due to the presence of earth's magnetic field, the harmful solar radiation cannot reach the earth's surface and they get deflected. So the earth's magnetic field shields us from the harmful solar radiations. So the earth's magnetic field makes planet Earth habitable, and therefore in absence of Earth's magnetic field, our planet Earth would have been destroyed by the harmful solar radiation. So we see how important Earth's core is for us. The Earth's core has magnetic elements like iron and nickel, because of which the Earth has its own magnetic field, and this magnetic field not only helps us to set direction but also protects us from harmful solar radiations. So in this video, we discussed in details about the central part of the Earth, that is core. And in our previous videos, we have already discussed about crust and mantle. We know crust is the outer layer of the earth and mantle is the middle layer of the earth. In this chart, we can see the differences between the three layers of the earth. The earth's core is in solid state. Mantle is composed of semi-solid rocks, whereas core is almost solid. Now, the depth of these three layers also varies, and core is the thickest layer among all. The temperature of these three layers also varies. Now, both these factors, temperature and density, increases with increase in depth. Then, all the three layers of the earth, that is crust, mantle and core, have two divisions. Sial and Sima are the two divisions of crust. Mantle is divided into upper and lower mantle, whereas core is segregated into outer and inner core. Now, the composition of these three layers are also different. Now, you can pause the video and note down the differences between the three layers of the earth. So in this video, we learnt about the central part of the earth, that is core. Then we also learnt about the two divisions of core, that is outer core and inner core, and we also understood the differences between outer core and inner core. And lastly, we discussed about the importance of core. In our next video, we will learn about the continental drift theory and plate tectonics. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at deltastep.com or download the DeltaStep app to learn one-to-one with our amazing teachers, or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million+ questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.